How I will impact chip design and designers. How AI is reshaping EDA and could it will help chip makers to focus on domain-specific solutions. Experts at the table, semiconductor engineering sat down to discuss the role and impact of AI in the chip design with Chuck Alpert, Kenneth Fellow, Satishi Balasubramanian, head of product marketing and engineering director for customized Siemens CDA, Anand Thiruvengadam, senior director and head of AI product management at Synopsys, Shailesh Kumar, CEO of Biosystems, Mehir Aurora, head of engineering at a Chip Agent, Darren McLennan, project manager at Keysight, which follows our excerpts of that conversation. Find part of the details discussed here. SE, where we are with the AI in terms of how do you see it playing into chip design. McLennan. AI is transforming the microwave and 3.5 design processes as well as the system and applications surrounding them. If you look at the 6G, the entire physical layer is adaptive. Those designs are configured on the fly, and they are requiring different architecture to provide an experience so that the design tools underneath them are changing. But also what's delivered and how it's used is going to be needs to be more dynamically rated. Thiruvegadam. If we look at what is really driving AI, the blocks we see today in computer are getting pushed to the limit. Deep design in general is getting pushed to the limit. Compute, memory, interconnect, and then that is compounded by the shorter development cycles. Right, you have many of our tier 1 SoC customers going to yearly lines for development cycles. And then there is one more aspect to it, which is the talent shortage. If you take the design getting pushed to the limit, compounded by shorter development cycles and talent shortage, that's a perfect recipe for a disruption from AI. AI is going to be pervasive. It is going to impact every aspect of the chip design, and we see it as a horizontal that's gonna impact every vertical from a design and verification point of view for the entire flow from aspect to the tape out and beyond. Alpert. In the short-term terms, we are trying to improve the designer productivity. One of the ways to do that is help assistance and code generation. A lot of what we do is ticker scripting, Python scripting, and in Cadence, Skill scripts. We generate a lot of collateral, including assist constraint, which helping with those kind of very mundane tasks and accelerating them. As we hire junior engineers, they might not have the ticker expert anymore. You can use natural language to do your debug. Those are short-term things that will really help aid productivity, but that's not changing the way we do design. What will change the way we do design is when we start building agentic workflows, when we have agents discover different tools and then use those tools to optimize around that. That's why it's gonna be the game changer. So there are two areas of focus. One is just the productivity, and the other is an agentic workforce. However, AI already has impacted everybody horizontally across the entire stretch. People are trying to use it for code generation at every level, up and down the stack, the front end, the back end, all the way to Judea and beyond. What we are really interested in is that as AI accelerates dramatically under the soul of crucible of constraint, for humans start to become the bottleneck for many different agentic workflows. A lot of serious progress is gonna be made by expanding the vertical. Many serious verticals within hardware design are gonna be carried out completely end to end, because this is the only way you can further accelerate progress. We are dealing with the monumental tasks here, the Tier 1 SoC. If you got a 1 year tape out timeline for every single generation, how do you even do that? How do you continue to compress and continue to accelerate unless you can take some of these entire verticals end to end? That's what we are very interested in. The latest crop of the foundation models is making this possible with one set. It, sorry, it making this possible with the onset of the reasoning models, fully agentic end-to-end training, especially with the reinforcement learning. We are going to see this happen, and that's where the industry needs to head. Kumar. AI definitely is changing the whole computing paradigm. 10 years ago, the entire compute was based on the CPU compute and x86 and the ARM. Now the lion's share has moved to a GPU-based computer architecture, so the computer architecture paradigm is completely changing, and we are still in the early phase. We are doing GPU-based compute and accelerator-based compute, but it's just a matter of time before we get into the true neural compute and those types of things. New software paradigms will come as a result of that, because software always follows hardware. Once we have a mature software and hardware platform architecture, then the software will start to develop around that. That's already happening with CUDA and other things. As this transition happens, there will be lots of opportunities for everybody. We are finally seeing the massive amounts of investment coming into the hardware world. The chip industry, from a vicious standpoint, was mostly dormant for the last 2 decades. NVIDIA is the most valued company now, and it's a chip company. This is impacted every aspect of hardware, the software, IP, CAD, tools. Engineers wanted to change things and build new things, and this is a great opportunity for that. Balasubramanian, we've been doing AI for a long time. AI is a pretty loaded word. It includes the machine learning, reinforcement learning, Gen AI agent and agent AI. Within the EDA industry, we have several projects that already are doing machine learning and reinforcement learning. We view it as a hybrid AI, where you have tools within tools and ML and reinforcement learning already built on the top of that is Gen AI and LLMs coming into play. But biggest change is that customers are telling us, I don't want to hire tool expert, I want to hire a domain expert. So with the Gen AI, agentic AI, I look at things that you are not gonna solve every problem. It's not a vertical flow. It's purely based on the use cases. It's not like I can go and type something in a tool and say, design me a PLL at 2 nanometer at this frequency. That's not gonna be happen today. It's still a long way off, but you can really easily automate a lot of manual tasks that have humans in the loop. So you don't need to have humans in the loop as often, but you still need them just to make sure it's correct. We are at this stage, but it's definitely a productivity gain. So, whose jobs are at risk? And are they really at risk? Or do they just need to retool? Albert, we have an our engineering talent shortage. We've had one forever. ED tools have made immense progress over the year. If you think about where the EDA is now versus only 4 years ago, the productivity improvements are incredible, and yet we still have a talent shortage. AI is gonna be improve our productivity. Let's say pick up a number. It's been 10%. Now it'll be a X plus 10%. Or instead of it being 20%, it'll be 30%. That's great. But we will just have more work for them to do. And they will have to change their skill set. But they are engineers. They there's engineers. They always change their skill set because they are smart people. So I don't see anybody losing their job, at least not in the next 10 years. Thiru Vengadam, a talent shortage is one of the most fundamental problems we have in this industry. The other thing we should look at, especially when it comes to agent AI, is the opportunity to offload highly repetitive tasks to agents so that the humans in the loop can focus on high value tasks. That's value creation. So humans will be focused on the higher aspects in the in the value chain, and the lower aspects are being offloaded to agent. That's one way to think about it, and it takes away the negative connotation of the AI is gonna take away engineering jobs. That's an important message to drive out the industry, because when you talk to customers and show improvement in the productivity and turnaround time, and the first question they ask is, can I reduce my workforce? How much cost savings can I extract? But that's not the right message to share with the industry. It's more about how to get engineers to do more with the existing resources or to accelerate innovation engineering velocity. Bala Subramanian. From the customer side, I do see kind of thinking. They're a little bit scared. But if you go back 20 years ago, we used to do layout differently, and at the time, people thought they were gonna be lose their jobs because EDA was going to take over. But we just started doing more. We are at a very good stage where I can go hire people for their expertise. That's a key. Customers are really focusing on the problem they want to solve rather than figuring out how to use what I call passive software, where we provide them with EDA software and customers build stuff around it. We are transitioning to more interactive software where it's easier for customers to start automating. Airport. Those were polygon pushers. Pushers. But if you can't adapt to the new recipe and you are at risk, we are engineers here. Everybody should be able to do that. Kumar. We have gone through centuries of disruption, starting from industry age, the motor, telecom, the internet, and every time we thought half of the population is going to lose their jobs, but it never happened. We are finding things to do, and the people who are going to excel are the ones who are going to use the latest cutting edge technologies and tools. In my view, AI is an amazing tool, and whoever is going to be able to leveraging and effectively to provide some sort of values or service going to be succeed. Albert, for the general population, I do think there is risk, but for the engineering population, I don't see it. Kumar, even non-engineers will benefit. There's always a way to provide some values to others that they are willing to pay for. Albert, but certain jobs could automate it out of existence. Most innovations happen over time, so there's time to make those changes. But AI is accelerating at such a pace, there could be a huge swath of jobs that will change. We are talking about AI in the kind of the additive way, 10% of the time. But to think about it as a force multiplier, especially for small teams today, this is the best time for someone with a little bit of a domain expertise, a little bit of a senior experience, and maybe you've done a tape out to start your own company. You can start your own effort because you can use agentic AI to carry out the huge swath of the verification and design effort to make those designs a higher quality. You could have a smaller, more focused teams with more design domain expertise. There's an infinite demand for more specialized hardware and for the AI accelerators and the algorithms do changes every 6 months when a new set of paper is published out of frontier labs. We need better algorithms for attention. Maybe we'll need better algorithms for state space models and so forth. In the future, there's gonna be a huge amount of demand for all this specialized material to come out of the air. So that's why people who have a little bit of a senior expertise are gonna be doing remarkably well. They are going to have a numerous force multiplier on what they can do. The big question is what happens to junior positions, and this has always been the case with disruption. McLennan, I agree with the point on a differentiated design. Automating things that are poorly differentiated and just sort of monetized. There will always be these frontier designs on materials or processes or applications that push the edge of what ever been done before. And you're always gonna have a human hand architecting the automation of the mundane to liberate the novel engineers. But when you automate entry-level jobs out of the pipeline, where do these experienced people come from? That's a challenge for our university educators and the pipelines of matriculating new talent. Tiruvengadam, for any of the EDA vendors, it can not be focused on the one persona, it's focused all of the persona. For any chip design, you have an junior engineer persona with a certain level of tasks and responsibility, a middle level and a senior level. When we develop the solution, we have mapped those personas. There is a set of a problem that can be addressed with the agentic AI. So I'm not too worried about the junior engineer being pushed out. Kumar. But if you look at the venture capital backed startup, there are $1 billion companies that have less than 10 people. That's a single digit workforce with $1 billion plus valuation. And VCs are looking for their next $1 billion company with one employee, and they are claiming it will happen next year. From that standpoint, if you have very concentrated wealth, it is going to be a great, very interesting trend in terms of implement. but then the money always trickles down. The person who is a billionaire is gonna create more employment. Airport. And if one person create $1 billion company, that it should be copyable, and the other people will copy them. Balasubramanian, exactly. You have to differentiate it between what's commercial and what is solving complex problems. So there are certain standards from us to our customers. I can't have a caliber, give a long whistle, that's a sign of. If I'm ruling out on an AI technology in caliber, it needs to be corrected to physics. That's important. Today I read this article how AI will impact chip design and designers. Thank you for your time. See you next time.